Hello, everyone. Welcome to our Build with AI on Google Cloud study series. And today is the last session, and we're very happy for you all to join us. And just quickly, 5 minutes intro before we get to our next speaker. I'm Margaret, and I am an organizer of GGG Seattle. And we have Inchi here as well tonight. Hello. At GDG Seattle, we have been around for a while. I have included some of the pictures here to show you the events we have, as well as a link to join us on LinkedIn. Pretty, we cannot hear you.
I'll take these off. Is this better?
Better.
Yeah.
Okay, perfect. Hello, everyone. I am Preeti. I'm the organizer of GDG Seri chapter. We have been collaborating with Margaret, GDG Seattle, and other communities. We are pretty new. It's just been 1 year, and the pictures include our team. Some of the members are not yet been added to the slides, but yeah, we are there, and we would love to collaborate with you guys as well. Thanks, Margaret.
Great. Thank you. Pretty. We also have GDG Vancouver and the GDG Burnaby as our collaborators. Today's agenda, just a quick 1 minute overview of our study series for those of you who are new um, to this event series. Then we'll have two talks. In the end, we will have Q&A. So the study series, I included a blog post that I've written about the different generative AI paths on Google Cloud Skills Boost. You can read about it later on. We'll share the slides. And here are the 5 generative AI paths. And today is the last session. We're focusing on deploying and managing Gen AI models and MLOps. And the topics we have have not been limited to the Gen AI path on Google Cloud Skills Boost. And we typically have 2 talks and then Q&A. A Cloud Skills Boost learning path has multiple courses. And I think after the first talk, we will take a poll to see how you all are doing in terms of your progress. And some of you may be new, and we can also help you at the end of the Q&A session to help you set up and answer your questions. And so if you signed up with our event, you should already be able to have the free credits to Cloud Skills Boost. If not, again, in the end of today's session, we can help you. All right, so please welcome our first speaker, Vinu Ravinkuma, to talk about AutoML meets Model Garden. So now I'm going to stop sharing Vinu, and then you can share your screen and go through your slide. Is that okay?
For sure.
Thank you. So I just stopped the sharing.
1 second. Just trying to start the share. Right, folks. If you're able to see, hi everyone. I'm Vinodini, and I'm thrilled to be here at GDT's Build with AI to talk about the exciting intersection of AutoML and Model Garden. At Microsoft, I collaborate across teams to drive AI-powered experiences across multiple product lines, and I'm also the founder of Mind Mosaic AI, where we harness AI to empower neurodivergent productivity. To start out with, let's go on to the first slide. So in this slide, we will mostly be exploring our agenda. We'll explore how automation and self-improving models are transforming AI workflows, start with what is AutoML, Model Garden, go through architectural details of each, what is the intersection of both, and go through a few demo slides here. As we start with understanding what Model Garden is. So, Model Garden on Google Cloud is basically an initiative that provides us pre trained machine learning models that we can use for various applications. Users can also use the pre trained models to fine tune their own data sets on them to be adaptable for unique tasks. And the way it improves efficiency is that developers can save time and computational resources. instead of building something from scratch, like models like Llama, open source models like Llama 3, Llama 3.1 or 3, all of them are available on Model Garden. So if you look at this slide, on the left you have the landing page of Model Garden, and on the right you have some details about the architecture. So it's more of a hierarchical architecture, which it works on top of model repository and kind of enhances accessibility through the hierarchical architecture. We also have support for multiple different frameworks like TensorFlow, PyTorch, and JX, providing more flexibility in terms of deployment. And the model repository, like I told you about, not only contains foundational models, but also contains fine-tunable models if you look on the bottom. I will be showing some of this in the demo, but this is just an introduction. Some key features, like I told you, pre-trained models, ability to fine-tune it's also kind of optimized for production, which means is that it's pre-optimized for deployment, and it works across multiple environments which are production-based, and also supports one unique functionality here is that it supports multiple modalities, which means it can be used for speech, vision, and multimodal tasks that are involved in multiple NLP processes. Now, let's look at what Vertex AI is. So, Vertex AI is the next generation AI platform in which Model Garden is part of. And if you look at it, the way it's actually structured is that it is not only used for deploying models, it's used for building them, deploying them, and also it's an end-to-end management framework for ML models. So Vertex AI contains the ML platform. It also has the Gen AI features on top, which contains Model Garden. Another look at what is included in Vertex AI is that, so if you look at it, bottom to top approach, you not only have the environment, the notebooks, the pipelines that are needed for the orchestration, but you also have the end-to-end modeling process, which starts with labeling to feature engineering to prediction to continuous monitoring. This forms a cycle for explainable AI, and we'll talk about that in later slides. But the most important part is that Vertex AI already includes AutoML, which means AutoML is a part of Vertex AI, where we'll talk more about what AutoML is. So, what is AutoML? AutoML actually stands for automated machine learning. So, AutoML streamlines the process of implementing ML models without actually needing extensive expertise, which is quite important for folks that are in software engineering and in other streams who actually want to get into ML machine learning without actually having extensive expertise in it. So, one example is that traditional machine learning involves your model selection, hyperparameter training, all of which need expert knowledge. With AutoML, it will automatically select the model for you and customize hyperparameter tuning for you, which means is that only thing that you would need to know is your own domain to be experts in that area, and this reduces a lot more manual effort. So, look at this: is that AutoML automates all of the repetitive and manual machine learning tasks. It's quite flexible. It's also quite transparent. Each step will give you like artifacts that are created out of that step. And it's also integrated into other things like feature store and model metadata, which are very good for tracking your experiments. Right? And there's very less monitoring overhead in terms of running production services. So, what are some key features of AutoML? Right. So, we talked about AutoML being a pipeline. So, what are involved in the pipeline? AutoML does pre-processing for you. It automatically handles missing values, performs feature selection, and normalizes data for your models. And it helps you in evaluating different models and selects the best one for your data set. It also helps in hyperparameter tuning. Basically, for those who don't know, hyperparameter tuning is just optimizing your model's parameters to make sure that models are as effective as possible. Now, training and evaluation is also automated. You'll see that in the demo where it'll automatically provide you a percentage in terms of training and the deployment. Since all of this is integrated with the Vertex AI suite, it is quite easy for us to monitor the deployment from start to finish. So we talked about all of this. This is what we talked about. What is the one thing that's missing here? Yes, the central model repository. That is where Model Garden comes in. Is that Model Garden gives you fine-tuned or foundational models that AutoML can interact with and make further customizations on top. And this is how AutoML workflow actually works. Is that AutoML workflow provides you a way for you to orchestrate your ML experiments without actually having to rely on anything outside of Google Cloud. Every model that's available is already available in Model Garden. And that is basically the intersection of AutoML and Model Garden, is that AutoML streamlines AI development with Model Garden, making it more accessible to developers. There's reduced costs because of having pre-built models, so you don't have to go anywhere outside of Vertex AI, and rapid prototyping. You can run multiple workflows at the same time in parallel using the same set of models and with different data sets and different parameters. So it's very easy for you to experiment and produce results. And how does it leverage Model Garden? Is that it recommends the best pre-trained model for the Model Garden. It also helps you in fine-tuning and ensuring that the best model adaptation is selected. It's also quite scalable, meaning AutoML's pipeline is completely automated, which means is that as long as your data is real time, it can actually support real time applications as well. It also continuously monitors your performance. So let's start with what a typical ML workflow for you would look like when you try to integrate Vertex AI into your workflow. Normally, you would try and gather data, prepare that data, train, evaluate, deploy, and predict. So the next slide, we'll go through some demos in that regard. So this this is the first demo is actually creating a data set on Vertex AI, and this is the data set that will be used to train your model. And if you look at it, I'm on Google Cloud's, the base page under Vertex AI. I go under Vertex AI Studio and select data sets under data. And in here, I'm going to go and create a data set and name that particular data set something specific to the kind of data that I'm using. You could name it to anything. And for the purpose of experimentation, here I've used single label classification and not multiple label classification, but you can use any kind of classification. And also use Google Managed Encryption Key for better encryption. Right? So this is a music data set. And one thing it's asking for is import images from your computer into that data set. So now, what I decided to do was use Kaggle's music data set that I downloaded online as part of this experiment. And the part that you're not able to see here is that it's actually trying to get images from the downloaded data set and upload it here. That's getting opened in a completely different widget that's not showing as part of the demo. Now, after I've selected around 100 images of musical instruments, and these are getting uploaded. And I'll forward this. And if you see here, all of these 100 images have been uploaded from my computer into this particular data set. And what happens next is that it will get stored in a cloud storage part, and the upload in itself will take time. So once I click that, I'll stop with this particular demo and go on to the next demo, which actually talks about once the data set's actually downloaded. So going on to the next slide, I'm having some issue. Yeah, this is the thing. Okay, now we'll reach to a demo where the data set's actually already uploaded. And if you look at it, I have about 100 data points, of which 22 I have already labeled, 69 are unlabeled. And there are only two labels in this, which is basically music instrument versus person playing music instrument. You can also see that as soon as I want to kind of train a new model, I can actually select the model training method as AutoML, which means it's completely minimal effort. I don't need to worry about hyperparameter tuning. I don't need to worry about any other kind of model parameters. Right? So I chose the AutoML. If you look at custom training, you can also look at like your own customized stack. I choose to deploy to an endpoint in cloud. I changed the pipeline name this is basically creating the pipeline for training. So I changed the pipeline name to music attuned. There are advanced parameters, and those are basically as selecting the training split, training versus validation versus test. As I said, all of this is completely automated, which means you don't have to do anything other than setting up these parameters, right? And once you've set that, you continue. And I choose higher accuracy in terms of like latency estimates, mostly because of the fact that I have a better network. And there's another thing that you can do in terms of incremental training, but I don't really do the incremental training because there's no base model to train on. You can use incremental training if you already have a base model. I don't. And once this is done, I will continue from this point on. And this model training effort in itself will take about 1.5 hours based on my maximum node hours. And the maximum node hours is based on your budget, right? I have just selected 8 maximum node hours based on that's the minimum. So this whole training process of your model is going to take 1.5 hours based on my training set. Yours could be completely different. I will move on to the next slide where we will go and talk about um, what happens after the training's finished. So if you look at this, the training is actually already finished. It ran for 1 hour, 38 minutes, and it's an image classification problem. And these were the point-wise evaluations that were done. So if you click on those evaluations, you'll see what was the precision recall curve and precision recall by threshold. These are all things we can talk in detail in another section, but this actually talks about what were the different things that were done to evaluate the model. So now we have the model. What do we do next? We have to deploy it, right? We have to deploy it and then test it. This is the deployment. And I am trying to deploy it to an endpoint. An endpoint is basically a VM instance on Google where it will generate its own API handle so you can directly query that endpoint. So now I have only one, I'm choosing only one compute node. So based on one compute node, I'm saying that 100% of the traffic can go to that compute node because it's just a test model. But you can, of course, based on your number of nodes, allocate the traffic split. It's just like a load balancer in the backend. So the deployment of the model in itself will take some time. But this is the demo that I wanted to do was that it once this deployment is done, you can go and query that API for predictions, right? Like you can give it any model, any image, and see how it actually performs. This is the end-to-end cycle. It is as easy as going and providing your own data set and just deploying it. Now, this is done. And so let's quickly, I have only a few minutes, so I'll quickly go with what are some challenges with AutoML workflows, right? Model interpretability. All of this is great, but all of this is automated, which means is that understanding AI decisions becomes a bit more complicated because of how automated things are, and which is a major problem, right? It's not as transparent as we would want to be, but Google is making more and more efforts into making it as transparent as possible. I'm sure in the near future it will become completely interpretable. Data privacy and compliance. Fine-tuning models on sensitive data necessitates that we need stricter handling and processing of information. Having all of that integrated in the workflow will also provide better security. And computational costs, like I said, I trained only on one node. It becomes quite expensive as you train on more nodes. So this is quite computationally intense as well as cost is high. So future improvements could be reducing costs there. So what is the future of AutoML and Model Garden? Model AI development. We talked about voice, we talked about video, but if all of that could be integrated in one single AutoML pipeline, that would be the future. Federated learning integration, which is basically making sure that I talked about the data centralization and security, that would be included as part of this. And federated learning also means is that you can get data from different sources without actually compromising privacy. And greater explainability, which means we talked about it, focusing on how models make decisions and making it as transparent as possible would be the future. So conclusion, this is the convergence of this is a significant advancement in AI. it improves efficiency by like at least 100-fold in terms of making machine learning engineers as well as folks coming from other backgrounds accessing solutions like that. And moving forward, it's quite critical to address these challenges so that we can move forward and maximize the impact of certain solutions like this. And that is mostly it. Thank you, everyone.
Great. Thank you so much, Vinu,
For sure.
for the presentation. And I don't know if you still have time for like one question or
Yes, I can take questions.
okay. Maybe we'll just take like one question
Mhm.
or two and then before
One
we
or
move
two
on to
should
the
be
next
good.
one.
Yeah.
Yeah, Pretty, would you like to get the
The
question?
question on the screen is what provisions are being made for insecure models working with secure internal data? Is there an access solution?
I'm sorry,
Pretty,
Preeti, I'm
we
losing
cannot
out
hear
on you.
you. I think your headphone is
Might have,
working today.
yeah, they have been playing, yeah, today. I don't know. Okay, I'll repeat it. What provisions are being made for insecure models working with secure internal data? Is there an access solution?
So all of the models that have been posted on the model registry have already been vetted by Google's model security process. So they've already implemented model distillation, adversarial training. They also conduct robustness testing. They also make sure to use backdoor resistance techniques like neuron pruning, anomaly detection to make sure that there aren't poison models. In terms of the data and model integrity, uh, they do they do a lot of data sanitization to remove harmful biases. They also try and encrypt the weights to make sure that there's no unauthorized model tampering. And they also rate limit and monitor so that there aren't excessive accesses to the model in terms of like output filtering. Uh, so there are a lot of things that are done from Google's side. The transparency that I would actually be expecting is more in terms of like if a model actually makes a particular decision on your data set, how did it come to that conclusion? Like a step-by-step approach. We're not there yet. It is more of a very subtle interpretability, and that would be the future, isn't like being able to talk one to one and say this is how I made the decision would be the model's interpretability.
Perfect. One more question. When
Yes.
AutoML creates a
Mhm,
model, can
mhm.
it be exported and used on other platforms?
That's a very good question. Currently, I don't think the model can be exported. But if you do kind of choose to publish the model as an open source model, so that the rest of the community can access it, then it can be exported out.
That's amazing. Thank you. Yeah, I think those were the two questions.
For sure.
Vinodini, thanks for answering, Vinodini.
Yeah. Thank you, everyone. This was wonderful.
Great. Thank you so much, Vinu, for speaking at our event.
Thanks, Margaret.
Yep.
Thank you.
All right. So we're gonna move to the next speaker, and we don't have the slide. And Vikram, would you like to share the slide, and then, or I can just introduce you. We don't have to go to that one slide about you. Okay. So everyone, please welcome Vikram, and he is a MLGDE like me, ML and AI, ML, and cloud, like me. We're from the same community, and we're being a good friend as well. Vikram has been speaking at GDG Seattle since a long time ago, 2018, 2019. So
Yeah,
almost every year we always have Vikram speaking. So I'm super excited to have you back joining us tonight for our last session of Build with AI on Google Cloud.
awesome. Thank you, Margaret. I'm going to start sharing my screen and then we go in here. All right. So I'm hoping everybody can see the screen.
Yep.
Yes. Nice, perfect. Okay, so today I'm just gonna go into slideshow mode. There we go. Okay, so today I'm gonna dig a deeper a little bit into responsible AI in the age of Gen AI. So hi, my name is Vikram. I'm a machine learning engineer at Assembled. I'm leading the team there, and I'm also a GD for cloud and machine learning, as Margaret already mentioned. Um, so what is responsible AI? So when we think about responsible AI, there are a few different categories that I like to think about them. And previous speaker already talked a little bit more about how Google's model garden is taking care of some of the components of responsible AI. But when I like to think about it, I like to think in three different kind of buckets in here. So there's like fairness aspect of it is where hopefully I don't have to explain what AI is, but AI is doing certain kinds of tasks for us, and in those tasks, what we are trying to go for is the model outputs are the model outputs fair, and you can measure those in different ways. There's of course like fairness as itself a metric, but you can look for diversity of the outputs that it's doing or diversity of the data that it was trained on. Also, is there transparency in the kind of outputs that it's generating, kind of data that it was trained upon. So fairness generally starts with the data set that you're using to train. Then we have ethics. Ethics around how you are utilizing the data and training those models. So there's around things around like privacy. So did you use privacy practices where you are removing PII information from the models before training those? Is there human agency and oversight over these models that are being trained? Because oftentimes we have these pipelines set up, data comes in, nobody looks at it, and it automatically becomes part of this training pipeline and ends up being embedded in the model. So are there human agency and oversight around that, and even around like the model deployment itself? Then of course there's societal and environmental well-being. This is a topic that has become more common now with LLMs, where every time you ask a model what is the weather today, it ends up actually computing a lot of it uses a lot of compute, which essentially um, is now that compute is much higher than what it used to be, and that's why these concerns are becoming more and more visible now, and everybody is thinking more about these, and we are going to the point of making smaller models, faster models, using less compute and stuff like that. On the last side in here, of course, like training of these big models. Before we even go there to the safety, the training of these big models takes up so much compute, so much horsepower that people are worried about how often we are training these models. And of course, there's a cost perspective to it, but there's societal and environmental well-being as well. The third concept in here that I like to think about is safety. So once you have the final model output, how robust is that model? So people might already be aware of jailbreaks that people are using, where LLM generally won't give you an answer, but you can ask by saying, my grandma used to tell me a story about X, and then it generally jailbreaks around it. So those are like robustnesses that you have put up around your models to make sure that people are not able to use your models for nefarious purposes. Uh, then the flip side of that is interpretability, where you want to be able to say, why did your model come to a conclusion based upon the input that you have provided, that was provided to the model? And of course, accuracy is very important in here. If your model is used in, I'm assuming like healthcare purposes, let's say that, and if you do misdiagnosis, that's a really big flag. So accuracy is like, again, a lever that you can pull around to see how much, it's a knob that you can move around to see how accurate your model should be based upon the domain that you're working on. But generally, good accuracy is important. And then accountability at the end of it. This has become a very hot debate recently because of LLMs, where the accountability is all over the place. You don't know who is accountable when a model makes a mistake. Is it the data that was provided to the model? So the website where you probably scraped the data from, or is it the model builders who did not clean up that data, or is it actually the person who's asking the model for that specific prompt to generate that kind of output? Who's the one responsible in this? So who's the one accountable around this? And this also includes like going back to the original part in here in the non-discrimination metric or fairness around when you're using this data from different public website providers, is that fair use? Because you are using probably the intellectual property when you're trying to train these models. So it's like a it's a never-ending cycle. There's a lot of things that components that come into this place, and all of these are kind of important. We all like to think we are responsible people, and we would like to continue this and be fair and have ethical standpoints and provide these models safely. So how was this done until now, until recently, where we had existing machine learning models? Machine learning models aren't new, they have been around for a while. So how was this done until recently? Until recently, most of the models were discriminative. So what that means is like this identifying between a cat and a dog. Discriminative generally involves a set of categories that you're looking at. So there are some guardrails or some the way I like to think of it as like there's a space of possibilities that you are aware of, and if since you're aware of the space of possibilities, you can look at what you're missing, what you are not including in here, which feature has been overly compensated, or has been there's not enough data for a specific feature. Things like that, those are easy to do, but those become harder with generative AI. So I just want to talk a little bit more about some biases that we have seen in the past on the discriminative AI side. So there's of course this selection bias, where, as I talked about, like the space of information that you're trying to go for. But for example, if you wanted to train a model to detect cars, if you are in San Francisco City, you probably see a lot of Teslas and electric vehicles. But if you are, I actually don't know about Seattle, but probably you see a more heavier trucks because they have to go up on the mountain. Or let's say if you go somewhere in the middle of America where the trucks are more popular rather than normal cars, the population segment or distribution there is very different. But if your training data does not include or is not representative of that population, then that's an inherent bias that you are including in your model. So that's called selection bias, where the training data is not representative of the population. Similarly, there's reporting bias in here. So if historically people have always bought, let's say, electric vehicles in California versus petroleum vehicles in other locations, and I ask in sitting in California, I ask, hey, suggest me a car. It suggests me electric vehicle versus giving me uh, a vehicle from the from like a petroleum vehicle as a recommendation. So this is again a reporting bias where because of historical data, these existing societal so, the example that I gave is not a societal bias, but there are societal biases that are present in our society. And when we are collecting the data, these data sets in the past do contain these societal biases. And if we train on the dataset without cleaning it up, without doing any modification on them, then these biases are now reflected back into our models themselves. Another segment in here is measurement bias. So this could be as simple as the tools that we are using to collect this data are biased. An easy example here would be like the cameras that we use to collect data set. If people are not familiar with this, Kodak is the company that came up with the color palette for how you take a photograph and the different colors that are shown on that photograph. When they originally were doing all this process of what should be a color look like, the model that was present was very fair and at that point not a representative set even at that point. But that ended up becoming the industry standard for what a photo looks like. So the tool itself of how all the phones around the world, like as the cameras improved, became digital, that stayed, that color combination, color model, I actually don't know what it's called, but that has stayed throughout for a long time until people figured out that, hey, oftentimes in darker shadows, people of color don't get represented very well. And the reasoning behind it is the color palette that we are looking at and in our photographs. So that's coming from the tools itself on how we measure these things and how we represent those into our data set. So that ends up becoming a measurement bias. Then, of course, there's one more, and these are not comprehensive. These are some examples that I generally like to talk about, but there's way more biases, even on like discriminative data sets or discriminative models. The last one that I like to talk about is aggregation. oftentimes what you will find is these discriminating models work well for majority of the population, or in general, if we talk about it as an average, it's fairly good. But there are specific population segments for which it does not work well, or it is very inversely biased towards them, where it penalizes their inputs, essentially. So an easy example here was this dispenser for paper towels at an airport, or I don't know, soap dispenser, where it wouldn't trigger for a darker skinned person versus if it's a fair skinned person. Like if I flip my hand this way versus that, it would trigger versus not trigger. So that's an aggregation bias. Generally, it was performing really well for most people, but for some darker tones, it would not work well at all. And that's a bias that it's very hard to detect, because generally you might be inclined to think that, hey, maybe there's something actually wrong with that, or like there's some feature that is in there which is actually causing the model predictions to be more inclined towards the output that it's producing. But until you, because like in average, your model is doing great, uh, so it's very hard to like come to terms with it and actually start looking into more depth, in more depth, to find out what is the reasoning behind it. And these are kind of hard to figure out. So okay, now that you know about biases, I generally like to do this presentation in person, so it's much easier to ask at that time, what is this? I'm assuming most people will say banana. So when you think of banana, is this what you think of? Or do you think of this? Or do you think of this? To me, all three are bananas. But people have different opinions. And this is where the subjective nature of generative AI comes in, where when I ask, now these models are not discriminative. They are not telling me this is a cat versus a dog. Now I'm going for, give me pictures of bananas, and it's giving me different pictures. So it is all bananas to me. But with generative AI, the problem exacerbates now. It's a much bigger problem now, because there's not discrimination happening in the in like a way that you can easily say that there's being discrimination is happening in here. But like even in this example, when I originally asked the model, so these are generated by Google Slides themselves, have a model right here where you can generate the images. And when I originally asked for cat, sorry, the model gave me the first two images in here on the left. It did not give me the example on the right side. I had to explicitly ask for that. As also not their problem, they only can generate 4 images at a time. But again, there's multiple things that are involved in this, just in this one process. When I asked for images of cat, they decided to generate 4 images rather than just one. So that itself shows you that these models are very different than what people are used to. People are used to seeing one correct answers from machine learning models, but now we have multiple correct answers, multiple possible correct answers. So even the way you present this information has changed. Oftentimes, when you ask these models for X, and if they give you directly the answer without giving you more varying viewpoints, always question that. At least I like to question that. You should as well. So that itself has changed the way. But also, as we are talking about in here, there is no objective way to determine whether this model did great or not, because I asked for a cat and all three of these are cats, but me as a user might prefer this brown cat in the middle. I don't know, tabby, I don't know what to call the, I'm not a cat person, but I don't know what to call the cat name. But some people might prefer the black one in here, or some people might prefer the white one. So when they ask the model to generate a cat and it does not generate the cat they had in their mind, to them, the model is not performing well. But that is an inherent bias that the person has in their own head about what a cat looks like, or what this representation looks like. So let's talk a little bit about a few different kind of biases that are available that are coming up with Gen AI based systems. So there's this confirmation bias. This used to happen quite a lot, where you'd be like, hey, this is a fact, let me look it up on Google, and you would search for the exact search term that you knew about. So your beliefs and your beliefs would get biased because of the searches that you're doing, and the outputs will be very similar to what you are asking for. This uh, Google did a lot of work, and other search providers did a lot of work to make sure that it doesn't happen. But now, with the age of Gen AI, these models are so eager to please you that if you tell the model 2 cross 2 is 5, it will happily agree. It might try to push you back a little bit, but if you force a little bit, it will go for it. So you can tell the model to go incorrectly on math. Everything else is just, math is very objective, but everything else is so subjective. So in everything else, it's so much easier to make it believe what you are trying to go for. So when you ask for a question, uh, even just those prompts, forget about data. Like there's of course a bigger challenge around the data itself, on which the model was trained. It's confirmation bias, because we collected the data on the problems that we know about, and based upon that we trained the model. But also flip side of this is where users asking the question, and even just that can cause big confirmation biases in here. Then, of course, there's another part where it's contextual bias, where the question that you asked, the model took it just a little bit differently. So one of the examples that I like to do is when I'm trying to learn more about a topic, I would often ask the model to say, explain this to a ML engineer. When I pass in ML, sometimes some models will take that ML as a Roman numeral and say 1006 or 1050, I forgot the number, but essentially they will say for 1050 engineer. I'm like, I don't know what that is. And then I realized that it's actually it's misinterpreting the context that it's reading, because ML is it's taking it as a Roman numeral. So this is model itself is misinterpreting the context and thus giving you biased responses. Um, Now, another part of option in here, which is becoming more and more prevalent with agentic AI coming in, is where we are trusting the outputs of these models blindly without verifying. So this came in early on when OpenAI launched the ChatGPT originally, that the students were just using the automation to generate the response and not even look at it and submit that as their out, and that their like the task, the essay writing task, for example. And the funny part was the way teachers were catching it is because the model started with I forgot the term, but it was like a very specific term that the model would always output. Yeah, I'm happy to help, or something like that, and then it would output the rest of the essay. And you just needed to look at that first sentence to say that this was generated by a machine learning model, not by a user. So that was because people started blindly trusting the outputs. They didn't even look at it. And we like to think that we are good at it as humans, where we don't trust anything until we see it with our own eyes and stuff like that. But once you start relying on an automation, you start trusting those without doing verification. And that's another kind of bias that comes in. Um, then last one that I want to talk a little bit more about here, which is kind of harder for most people to do anything about, is this feedback loop bias, where if people are familiar with how model training happens for these large language models, is we provide it with the input of a prompt and a sample output. Now, this is called fine tuning on top of the raw data that we already use. So there's already a lot of things that are in the raw data. But on this instruction fine tuning, this is called instruction fine tuning, where you provide it a prompt and then you provide it the kind of answer that you're expecting for it to output. Now, the kind of answer that you're expecting for it to output depends a lot on who you are as a person. So let's say if I ask the model, how far is Earth from Moon? Write me a function for that. For me, it would write the function in Python because that's my preference. But let's say when somebody who was training this model, they only always worked in C++. For them, the prompt was write me a function to calculate the distance between Earth and Moon, and their preference was to write the response in C++. So when model generated the response in Python, they marked it as negative. Now this goes back into the model as a feedback loop. Now the next time, model does not generate the Python loop, Python output. So this feedback is actually fairly common, where people realize, or people are thumbs down, like doing thumbs down on different kinds of outputs, and those go back into the system and end up either isolating a segment of the population or outputs or preferences of the user, or highlight certain preferences of the user. So if you an easy example here generally is the way I like to see is between Gemini and ChatGPT. When I ask a question, Gemini generally tends to prefer to do a lot of bullet points answers. It generally tends to not do big paragraphs. versus ChatGPT with 2 paragraphs. Again, this is personal, based on what I've seen, and it might be totally different for you. But what I look from that is a lot of people on Gemini team, or people who are labelers for Gemini models, they actually do prefer those bullet points, versus a lot of labelers on the ChatGPT team probably prefer a lot more verbose answers in more paragraph forms. So this feedback loop essentially causes the whole model to itself get uh, like more tuned towards one side versus not. And these end up going back into the model training and end up causing bigger issues over time. So how do we mitigate these biases? So if you are actually a builder, if you are building machine learning models, so then at that point, there are multiple things that you can do. So there are bias detection and mitigation strategies. So for example, you could do data augmentation, where if you have an image only in bright day sunlight, you could like try putting some filters on it, like going in, rotating the images, clipping the images. Those are some very simple data augmentation strategies. But you could also do like algorithmic adjustments in here. So if a population segment is overly present in your data and others are not, now you could actually use synthetic data to make sure that the data sets are not imbalanced, and they are well balanced. And still, synthetic data is still a question whether it works well or not. But you can start implementing some strategies. There's ensuring transparency and explainability. This is actually really bad with these large models, because you don't know exactly what is going on within these different hidden layers that are within this deep learning model. So there are some techniques emerging in here. There's shapely additive explanations and local interpretability, model agnostic explanations, LIME, I think that's what it's called. So these terms are coming in, where you can see for an input which different neurons or activation layers were getting highlighted or getting activated, and thus you can see why the model is going in one direction or another, and that might provide you with some more insight around the kind of model training data that you might need to make sure that the model is not always leaning towards one direction or the other. Then, of course, the last part in here is protecting privacy and security, which is around using differential privacy, using data anonymization techniques to make sure that your data set does not have any PII or any other information that could identify a person or leak some information. Now, if you are a society, this is the much harder task, where if you are as a society, what can we do? So some simple things like support ethical and regulatory frameworks. These are harder to do, but much easier in the terms of make sure that your voices are heard, make sure you are talking about these things I talk about at the end, where promoting public education and awareness is definitely one of the big issues in here, where if you are most people are not even aware of their issues, of their biases, of course issues as well, but their biases. So just being aware of your biases helps quite a lot, and just telling people or showing people that they have biases helps them understand next time, identify it by themselves. And one of the books that I recommend in this is called Invisible Women, which talks a lot about how these different kind of biases in our society from long time back to this day are causing issues with women in workplace. Like for an easiest example is the temperature setting at most of the offices. It's too cold for women. Our car seat belts are not designed well for women. They're more designed mostly for men. So there's a lot of these different biases that are in our society, have been around for a while, and the best way to for us as a society to talk about them or to get around them is to first start talking about them and understanding those. The last one, I can't change society, but I can hopefully influence you a little bit on how to fix this. Is for you as an individual, I would always say trust but verify. So when you ask a model for something, always look for sources that it used to generate that output. Always ask it to give you those outputs. Always ask it to verify the outputs it's generating. One of the techniques that people have started using is they ask the same question from 2-3 different models, and then seeing like how diverse their opinions are, and then asking a follow-up question on each one of those to see, based upon like what you learned from model A, ask a follow-up question on model B to see if the model B is actually able to course correct or get back to the correct answer, or can give you more details about why it thinks that the answer is incorrect. That's also the second point in here, which is look for varying viewpoints. So don't use, this is harder to give as an advice because all of these models do cost from time to time for like proper usage. There's free usages for all of these generally, but if you want to use it for all the time, they do cost. So it's kind of hard advice to give where look for varying viewpoints. So I'm gonna have to pay like $20 here, $20 there, $20 there. But it's a very interesting strategy when you're trying to figure out and make sure that you are not biasing you're not being biased by the one source of truth that you're using. And then the last part in here is being aware of your own biases. And for that, I suggest everybody to go to this Project Implicit by Harvard, and you can take a test. And that test allows you to see what is your current bias status looks like in your brain. And these are inherent biases. These are implicit biases that are in your head right now. Very hard to even understand what those are. But once you take the test, you get to see what these different biases in your head are, and maybe that in future will allow you to be more aware of these. The best way to fix the problem is first recognizing it. Then you can start taking actions towards how to fix it. And that's where I'll end. Any questions? That's me on Twitter. And if you want to learn more about it, now rather than giving links, I've started telling people to search for things. And you can search for this on your favorite platform. It could be whatever platform you prefer. So yeah, that's about it. And all the slides are available. I think those will be shared later.
Great. Thank you so much, Vikram, for the talk. A responsible AI is such a important topic, and I really appreciate that you make it so fun too.
Nice.
Right? Because I think it's not easy to make this important topic fun, right? I really like the example on the banana, the different type of banana and the cats.
Yeah.
So we ready for some questions, Pretty?
Yes, I do not see the questions on this Slido, but if anybody, yeah, okay, we have a question. How MCP can be used in MLOps?
So I think the person is asking for MCP, which is Model Context Protocol from Anthropic. And then in MLOps, I actually don't know about how to use MCP in MLOps because most of the times the Model Context Protocol, the way it's talked, the thing that I understand right now is what it's talking about is how do you connect your models to external systems or other systems to allow this LLM model in time to look or reach out to external systems to gather more information. So that's what my understanding of MCP is. But again, this is like a few months back when they originally released it. I haven't looked into those docs for a while. And I know that it recently became more popular. So yeah, I will have to look into it if they support something with MLOps directly in there. I see the other question as well. Can I just go ahead?
Yeah, sure.
Nice. Okay. So the second question is, why does Gemini Live support multimodal input, but it doesn't allow larger text files for RAG inputs? It accepts 20 KB text files, but not 500 KB. So I think this might be a limitation of the model context window. So most of these models, the way they are trained is there's only so much you as a user can fit in before the GPU itself on which the model is running runs out of space. So these model providers have given a certain length which is called context window, in which you can add in your details. So when you are uploading the files, I'm assuming this 20 KB text file probably has enough tokens. Tokens are the actual text converted into a format that machine or these models can understand. So once you convert these, probably those do not fit versus the 500 KB file probably overfills that. And that's why the live multimodal input starts to crash. So that would be my understanding. But what I would suggest is try, as a machine learning model, I love to do as a machine learning engineer, I love to do experiments in here. What I would suggest you to do is make 5 more files, go from 20 KB to 500 KB, make 5 more files in between, see where the limit is, and maybe you'll probably understand that the limit is around, if I remember properly, it's like either 8K token limit or 128K token limit. I don't know exactly where it is, or 32 K token limit, but you will find that out, or I'm sure there's documentation available. But yeah, it's probably token limit.
Okay, perfect. I think we are at time as well, Margaret. And yeah. Thank you, Vikram. This was good. It will be closer to 128K token limit. The smaller one is 20K tokens.
So I would just assume that your file is probably too big for the context to fit in the context. But I think I'll stop there, and feel free to reach out to me on Twitter and we can talk more about it. Awesome.
Great.
Thank you.
Thank you so much, Vikram, for your talk. And again, we were so happy to see you back to our event again. And everybody, if you have more questions, please post them to the GDG Survey Discord server, and we will share the sites with more like this with the information afterwards. And so we hope that you have enjoyed the 5 study sessions, join the Discord and post your questions there, and get access to the Cloud Skills Boost credits, and you can take your time and complete the 5 GenAI path on the Cloud Skills Boost. And then, you know, us, Preeti and I and Inchi and all the organizers, we really appreciate everyone stay with us until the last session, until the very end of the last session. So we want to we want to get winner for 3 people from today, right? And then based on today's attendance, and then we will follow up and look at the attendance, people who attended across all 5 sessions, and we will do a random drawing and pick 3 winners as well.